Asphalt is one of the preferred pavement materials for cities and counties for a number of reasons. It's cheap relative to concrete in its initial application, and we have a great many procedures for maintaining it, everything from pothole patching to crack sealing to seal coating procedures. But eventually there comes a time, after a sufficient road load from traffic and from the weather and the sun, that eventually you have to replace it. And that's a complicated process, and it involves a very sophisticated piece of machinery called a profiler. And the profiler comes through, and what it does is mill and grind the material up. There's a large drum underneath it with teeth on it that spins, and the operators set it to grind the surface material up. And then the asphalt provides an additional benefit in that you can recycle it and put it right back down. Now, the machine that's used to do this, the profiler, some people think of as a big monster machine that rips and tears and grinds and just comes through there like a monstrous chainsaw and cuts the surface all up. Actually, it's a precision piece of equipment. It's very complicated, and it's a very sophisticated piece of equipment that takes a considerable amount of training to run properly. Now, this video is to give you some of the high spots of how to properly run profilers. We were fortunate enough to have a contractor who does this sort of thing for a living invite us to one of his job sites where we could see them do a pre-operational inspection, give us an introduction to the control systems, and then show us step by step how the procedure actually works. How they calibrate the drum, and they set it every time. They set the drum to the ground, zero it out, so they can then dial in the depth of cut they want to make for the material. They'll show you how they actually cut the pavement, how they load it into a dump truck, how the dump truck and machine work together, and how the machine looks like as they move forward to mill the material up. Now, a couple of things in advance. One thing that's very important to do, fortunately we happen to have this landmine here. Now, to you folks it may look like a manhole cover, and that's true, that's what it is. But truly they are landmines to profilers. So while the parking lot we were milling up in this video doesn't show them, one thing you need to do if you're going to be profiling old asphalt is to get out your maps and plats, talk to the old retirees that have worked for the system for a while and know where they all are, and make sure you've identified any hard surface areas where you have steel manhole covers, things like that, because they will wreak havoc with the teeth on these machines, and it can be a very costly and expensive repair. In this video, there may be a question come up about personal protective equipment when used. Now, we know that we're in the work zone. We need to be visible because people lose their lives and are seriously injured every year in work zones, not only from traffic that's coming by, but also from equipment that's in the work zone, behind the barriers with you. And what the operators and what the drivers almost invariably say is, I didn't see them. So we always recommend vests that meet the ANSI standards for public vehicular traffic work zone vests, if you will. Now, you'll see the workers in this video wearing them. We also ordinarily recommend that we wear hard hats in any construction venue. It is the employer's option on running something like a paver where there's no overhead work present to use hard hats or not. Now, you will see in a maintenance operation in this video, one of the employees crawls under the machine to rotate the drum to inspect the teeth and remove a couple. In that situation, because his head was up where he could bump it material above and he could have debris falling on him, you'll see him putting on the hard hat to go into that specific environment. So we do recommend hard hats just as a matter of course, so if you need them for any reason, if anything happens, it's on. But employers do have the option under the standard not to wear them if they're not working in an environment where they're being concerned about material falling from overhead.
So basically what we're going to do is just a basic walk around. This is a 2010 W working 2100. The basic specs on this machine, it weighs about 83,000 pounds. We have basically a cutting drum width of about 7 foot 3 inches wide. The normal traffic lane is about 11 foot wide, so it would take us 2 passes to take out a lane full width. So basically what we have here is we have our tracks. Basically what this is this just a stabilizer for the machine. And then also here, what we have here, we have our back door. So this basically controls the back door so we can access the drum. And then also what it does is it helps us to pick up the excess material that the machine leaves behind. So we drag that back door on the pavement, and it actually gets whatever excess material that we're leaving behind. Basically what we have here, this will be an example of the kind of teeth that we use. This drum has about 168 teeth. So this is basically what we use. Normal wear and tear on teeth like this, depending on what we're cutting, you can probably get 2 or 3 days out of it, depending on if we're cutting 2 inches or up to 12 inches. Normal box comes with about 50 teeth per box. So it would take us approximately about 4 boxes to fill up a drum on the machine. What we have here is basically our electronic controls. So this is basically what my ground guy would control. So basically all he's doing is just setting the drum to whatever width or whatever depth that we want to cut. So it can be anywhere from 0 inches all the way up to about 12 inches. All right. Basically he has dual controls on each side. Basically here, this is an emergency stop button. So if we run into any problems on the job, he can just hit this button and it'll automatically shut down the machine. Here we have back leg controls. So what this does is it controls the back of the machine. These 2 buttons here, what they control is the turn radius of the machine. We also have this button here, which is our sideboard. We can control this, picking this up and down so we can see actually what we're cutting. We have basically our horn button here, and these are also sensor buttons here that go with the electronic box. Here what we have is basically emergency control for the back door. We can lock the back door here for anyone who's doing any work underneath there to prevent the door from falling on any operator. Here basically what we have is just our step ladder that gets us up and down on the machine. We always want 3 points of contact whenever we're going up and down the machine, and then also what we want to be aware of when it's wet outside, we want to make sure that we have a firm grip. Up here in the front, we have our basic cylinders, and this is all controlled also up top also. And what this does is when this ski is on the ground, what it does is it's a sensor that goes back to this electronic box, and that controls our depths. So we always want to make sure that this ski is always touching the ground so we can keep a level cutting edge. Up here, these controls basically mirror what we have in the back. So we can have the operator operating from the back or here in the front, whatever his position is.
What we're doing here is just basically lining the machine up and setting it in place. My ground guy is he already has his cutting depth on this particular project, which was 5 inches. And from me up top, what I'm doing on that right side is watching my ground guy to see exactly what signals and when it's time for us to actually move forward. And what he's doing is turning the tracks because he wants to really line it up so that we get into a straight cut. So I'm walking the machine into the cut as slow as possible until he reaches grade. And we always want to also, what I just did was just turn on the conveyor so that we can pick up any material as we go. Now in this situation here, we went too deep there, so the back door kind of got caught. It could have been on any mud or any kind of big boulders there. So what I'm doing here is actually just picking up the drum, just a hair, and then we're going to reset back down, and then we'll continue on. Now that we've set back in, what my operator is doing on that side, he's basically keeping that back door down, and he's walking the machine in from 2 inches down into a 5-inch cut. We're just still moving slowly there. He's measuring to make sure that we have the right cutting depth. He's also watching the back door to make sure that we're picking up all that excess material. What the operator up top is doing is just making sure that he's aligned, making sure that he doesn't run into, because we're dealing with a cut that's pretty wet. So we make sure our front tracks aren't walking to any hazards, any pitfalls. Now normally what would happen is, just based on this cut here, my ground guy, his job would be pretty much done. So what he would do is kind of move his position off to the side and kind of just guide the truck in its direction. But based on where we're cutting, he has to stand there in the back and just make sure that we're maintaining our depth, because the machine will continue to actually drop down on the soft material. As you see, the front tracks kind of dropping down there, and our back tracks are pretty much maintaining the grade. So he's just making sure that we maintain our grade and keep a level grade all the way across the cut. What we're doing here, we put the machine on level ground, and we're doing what we're called as a calibration of the electronics. So what he's doing is just checking to see that the teeth scrape the ground just at the level of 0. So he's basically zeroing out the machine to make sure that the left side and the right side are an even kill. So he will continue to adjust it until the machine actually scrapes. What he's basically doing here is watching that front ski to make sure that it has a point of contact, because without that ski having a point of contact, what it does is it throws off the cut. Because if you notice here, what he's doing is he's clicking that back door to make sure the back door is down and extracting the machine. He just gave me the signal that now it's time that I can move a little bit faster into the cut. And then what you'll see him doing is start to actually walk the back tracks. You'll see the back tracks start to come up, so that we have a smooth transition into our cut. At the end of each day, what we want to do is actually wash the machine down. Given this job was a job with a lot of mud, a lot of water, and a lot of soft ground, we have a lot of caked up material in our tracks, in our hoses, on our drum, and our conveyor. So we just want to make sure everything is sprayed down, because what happens is after that buildup of so long of not cleaning the machine, what it does is it's a wear and tear on the equipment. So we want to pretty much at the end of the day take about an hour and a half to just wash the machine down and make sure the tracks are free of debris, all of our cutting edges, our skis, and now if we had a project where we had a lot of dust, it'll be the same thing. We want to keep all of that dust. We want to get all that dust off the equipment, because this equipment is basically built on electronics. So we want to make sure that we keep everything debris free. At the end of every day, we want to spot check our teeth, which is one of the most important pieces on the machine. We want to make sure that our cutting edges are well taken care of. And what he's doing is just basically just removing debris to make sure that we don't have any obstructions on our next cut. The most important thing about an operator, we want to keep them on the same machine, because they're pretty much familiar of all the little mechanical issues or a little tinkering that we might have to do with the equipment. So what he's doing here is just spinning the drum, and we call it doing a spot check. So he'll check any holders and see if those are loose, because when those holders get loose, they tend to give us a bad cutting edge. And with the wear and tear on those, we don't want that to become an issue in terms of us re-welding a new holder. A new holder pretty much costs us probably about $60 per holder. And probably about an hour of labor time if we have to end up welding those. So just by him just taking 10 minutes at the end of the day just to spot check the drum saves us a lot of time and maintenance and downtime on future projects.
All right, basically some of our basic controls on the machine. As you can see, we have a lot of blind spots on this equipment, so we always want to be aware of our surroundings and where we're backing into. We have to notice the pedestrians, oncoming traffic, so it's always good that we have a guide, some kind of flagger or anybody just to watch out for any blind spots that we may have. Some of our basic controls that we have here is basically, this is our computer gauge. So everything that is controlled down there on the ground by our ground guy, I can basically see up here in terms of how many inches we're cutting, how much fuel we have, what our RPM rates are, and actually what our speed is. So this is basically like our speedometer and basically what tells us what is going on with the machine. It's also a diagnostic portion of the equipment also to tell us if anything's wrong. We have buttons here just like a check engine light to tell if there's anything wrong here, a diagnose button here. Here we have what we call is our beacon light. So basically this is our sirens. We have our left front track here button here and moves the machine left, up and down. The button here will control both of the legs and that'll move it up, down. And this is our right track. So we can tilt the machine in any direction. And this also mirrors what we have in the back. So we can do the same in the back. We can drop it down. These two buttons here are for our sensors. So whatever he sets down there, if we cut in 2 inches, he'll give me a signal. I'll hit these 2 sensor buttons. And basically what that'll do is drop the machine down into the cut. What we have here is our stop button. So we hit this button here that'll totally shut down the machine. And this is our ignition button. So basically it's a push start, this green button here. This button here is our emergency stop. So if we have any problems that we got to just hit the emergency button, we can't get to anything, we hit this button here. This button here is basically our idle up, so we can idle it up and we can idle it down. We always want to operate in the high idle just based on what we're cutting. Here we have a water button here that turns the water on and off. This button turns our conveyors on and off. Then we have a cutting button here that turns the drum on. Here, what we have is basically our conveyor controls. It controls the conveyors left, right, whatever direction we want to throw the material into the dump truck. Here we have our horn and our side plate down on the ground here, which our operator controls down on the ground. And these buttons here control our forwards and backwards motion. We can move the machine forward here, stop, and we can move it backwards here. So just forward and reverse. Pretty simple to operate. That's it.
Now this is too large a topic to cover in a video of this length, but if you would like more information or training, the University of Texas at Arlington LTAP program would be more than happy to help you. Please feel free to call us at the information provided below on the screen.